Hi everyone, welcome to our class. Today I'm going to discuss the language of mathematics. Language is a systematic means of communicating ideas or feelings by the use of conventionalized signs, sounds, gestures, or marks having understood meaning. This definition is taken from Merriam Dictionary. Language is very important for us to be able to connect with other people. It allows us to share our ideas, thoughts, and feelings with others. We use language so that other people understand everything that we want to tell them, and we, on the other hand, will understand other people too. If you have mastered cognitive language communication, that means you have already mastered a complex system of words, how to structure sentences, and the proper grammar used to construct ideas. Consequently, the more effective you can be in communicating with people. However, even if how good you are in your own language, that would be nothing if you are in a place where the language and symbols they use is foreign to you. Communication is only attained if people understand the language you are using. Do you know that there are 7,117 different languages spoken all over the world? This is from the Ethnologue. Each language is spoken and written in different forms. There are 170 languages spoken all over the Philippines. This is what makes the mathematical language unique from other languages, because the written form of the language of mathematics is the same all over the world. For example, this symbol represents 1. In some other places, they read this one isa or usa, uno, sayo, or one in English. So whatever language we are using, we know that if it is written in the symbol, we all refer to this symbol as one. Just like any language, the language of mathematics can be learned if you will exert effort to be familiar with it. This can be done through reading, writing, speaking, and understanding mathematical words. There are three characteristics of the language of mathematics. It is precise, concise, and powerful. Let us take, for example, the definition of a square. A square is a quadrilateral whose sides are equal and adjacent sides perpendicular to each other with equal diagonals. All these descriptions given in the definition are true. A square is a quadrilateral, meaning it is a four-sided polygon. The sides are equal. Adjacent sides are perpendicular. And then you have the diagonals are equal. All of these descriptions are true for a square. However, mathematically, we actually define a square simply as a rectangle of equal sides. So this definition is exact, very clear, and it is free from all elaborations. So instead of defining, giving all the descriptions, it is put into a single term, rectangle, because we already know the definition of a rectangle, that it is a quadrilateral whose adjacent sides are perpendicular. And that means if the adjacent sides are perpendicular and the length are equal, then that defines a square. Okay? Let us consider the following examples. How do you read this number? Okay, so if you read this one as 402, then that is correct. I just hope nobody read this one as 402 or 402. The proper way of reading this number is 402, emphasizing the place value of each digit. So 4 is in the hundreds place, and since there is no mention about the tens, we place in there 0 for the tens, and then for the units digit is 2. So we read this one as 402. 528 would means 5 is in the hundreds place, 2 is in the tens place, and 8 is in the units place. 528. Okay, so how do you read this number? So most of us would read this one as 3.58. We are not being careful or giving importance to the place value of the digits. The proper way of reading this number is 3 and 58 hundredths. So the and is used in here to denote that the succeeding digits is actually in the decimal place. So this is 3 and 58 hundredths. When do you use the expression 3/4 or 3:4? We know, of course, that either 3/4 or 3:4, this is represented by the symbol 3 divided by 4. So notice that even if they are represented by the same symbol, they are supposed to be used properly. So we use 3/4 if we are talking about portion of a whole. We say 3/4 of 1, 3/4 of 6, 3/4 of 20. So that is 3/4, portion of the whole. While when we talk about 3:4, we are looking at the ratio of two numbers. In simplifying equation, say x over 2 is equal to 3. How are you going to solve for x? So maybe you are familiar with saying you multiply the equation by 2. So when we do multiplication the equation by 2, then most probably you will arrive into this statement. X over 2 is equal to 3. We multiply this whole by 2, and that's it. However, this statement or mathematical statement is wrong. Because in the properties of equality, we don't have such property as multiplying the equation by 2. But what we have is you multiply both sides of the equation by a non-zero number. So in this particular example, we can multiply both sides of the equation by 2, which follows performing this operation. You multiply the left side by 2 and you multiply the right side by 2. That would now give us x is equal to 6. Okay? Let us consider this example. Solve for x in the equation 4x is equal to 20. So most probably you will say divide the equation by 4. That statement dividing the equation by 4 would allow us to say that 4x equal to 20 can be divided by 4. Take note that this statement is wrong because there is no such statement in the property of equality telling us that we can divide the equation by a constant. The property of equality that allows us to simplify equations such as this is it says you can divide both sides of the equation by a non-zero number. That means you have to divide separately the left member and the right member by equal non-zero number. And that gives us now the answer x is equal to 5. So this is how mathematical language is being precise. In every step that you do in manipulating a given mathematical statement, it must be based on principles given on how we simplify, how we can rewrite a mathematical symbols or statement. Okay, so mathematics language is powerful. Mathematics had always been part of everyone's life. From the simplest thing that we do, like buying and cooking, to making experiments and researches, which produces more inventions and discoveries. Everything that we use at home, everything that is sold in the department stores, vehicle that we ride, gadgets that we are using, the buildings, and almost anything we see and beyond our eyes are product of mathematics. That is how powerful mathematics is. Just like any other language, symbols are also used in mathematical language. So we use numerals to represent numbers. The Roman numerals was originated in ancient Rome and widely used in Europe until the late Middle Ages. Numbers in the system are represented by the combination of the letters in the alphabets I, V, X, L, C, D, and M. Each represents fixed number. I represents number 1, V is 5, X is 10, L is 50, C represents 100, D represents 500, and M represents 1000. Other numbers can also be formed using the combination of the letters in the Roman numerals. For example, 3 is formed by combining 3 i's. That means we have a 1 plus 1 plus 1 giving us 3. 45 is represented by the symbols X, L, and V. In the Roman numeral, if a number, a symbol with a smaller value is written before the symbol of a bigger value, what you're going to do is to subtract this value from the bigger value. So we therefore have 10 subtracted from 50. So this is 40 and 5. This is 45. 212 is represented by C, C, X, I, and I, which means this is a 100 plus 100, X is 10, then 1 plus 1, that gives us now 212. 67 can be formed by L, which is 50, X is 10. So this 10 now is added to L because it is written after the bigger number. So this is 50 plus 10 is 60. V is 5. So 65. I and I, that means 2. So we therefore have 67. So rules are followed to be able to form any other numbers using the Roman numerals. So I hope you now see the idea of the numerals and the number. So the number is the idea or the quantity of the object that the numeral is representing. So take note, when we compare two numbers, in Roman numerals, we do not say C is greater than L. We know, of course, that C represents 100 and L represents 50. So take note, we do not compare numerals, but rather we compare the value. So we do not say C is greater than L, but rather we say 100 is greater than 50. Okay? Okay, so another symbols which are used to represent numbers are the Hindu-Arabic numerals. This system was originated in India in the 6th to 7th century and were introduced to Europe through the writings of Middle Eastern mathematicians Al-Khwarizmi and Al-Kindi. It introduces 10 symbols, each represent a fixed number. So we have this symbol to represent number 1, this symbol to represent number 2, this is number 3, this symbol to represent number 4 and 5, and we have this symbol representing 6, 7, 8, 9, and this is 0. So take note that these Indo-Arabic numerals are actually now the universal symbols used to write numbers. Other numbers are formed by combining these symbols following specific rules, which of course I assume that all of you can write perfectly the numbers using the Hindu-Arabic numerals. This numeral system is used to represent numbers which are used in all our mathematical operations. So if in the Roman numerals we do not say C is greater than L to represent the statement 100 is greater than 50, this time when we use the Hindu-Arabic numerals we can now say 100 is greater than 50. Because we are really comparing in here the numbers that the numerals are representing. Other symbols which are used in the mathematical language are the letters in the English alphabet. In mathematical language, letters in the alphabet, either small letters or capital letters, are also used to represent either a quantity or an unknown number, also called as literal numbers. It is also used to denote a name of a set, a point, or any other quantity that you might need in expressing your mathematical ideas. It is usually convenient to introduce what the letter is representing for if it is used in problem solving. For example, let x be the unknown number, or we let n represents the number of terms, or we can let the ordered pair x and y represents the coordinates of a point, or we can introduce n to represent a set of natural numbers. Other symbols which are used in mathematical language are the operations or symbols used for the operations on numbers. So you must be familiar with these symbols such as the positive sign, or this is also used for addition. This can be used to denote a negative number or subtraction. This symbol can be used for multiplication. That is also used for multiplication. Then you have the pair of grouping symbols, which is used to group quantities, or this is also used for multiplication. This symbol is used for division. This can also be used for division or to denote fraction. This is used for extracting square root, cube root, and fourth root. There are still other symbols which are used in operations on numbers which will be introduced to you as you go along with those specific mathematical content. For example, in calculus, you will encounter the symbol d to let you find the differential of a function. The d over dx tells us to find the derivative of a function, and this symbol is for the integration. Other symbols are also used to represent constant irrational numbers and imaginary number. So we have this symbol to represent pi, the Euler's number, The golden ratio is represented by phi. Imaginary number is represented by I, which is defined as the square root of -1. Other Greek letters are also used to represent angles such as alpha, beta, rho, and other symbols. Other symbols which are used in mathematical language are the mathematical operators. The following symbols are used to compare or tell relationship of two quantities and considered as verb in a mathematical sentence. We use the symbol to denote equality of two quantities, not equal. So if the first quantity is less than the second quantity, greater than, less than or equal, greater than or equal. This symbol denotes the union of two sets, intersection, proper subset, subset, element, and not element, not an element. There are still other mathematical operators which you will encounter in specific mathematical content. So at this point in time, I hope you already appreciate the importance of knowing mathematical language, the characteristics of mathematical language, and the different symbols used in translating mathematical statements using mathematical symbols, which is our next topic. Okay, so thank you and